generate the series, right? So I want to lock the series. Because the second statement here, lock the series, right? Lock your series. So what is the commands in the EViews to help me to lock the series, right? So I need to use the ln and e equals to log into the bracket and e. Then you say, what is this? Right? So this command in the EViews, maybe not big enough yet. So this is the equals to log. Yeah. Yeah, I should put this one in the black color. And then this is your variable name. So this is my command in the EViews, how I log the series. So how to read this? So LNMD is a new name. It's a new name. I named for my series. So the purple color MD here is the variable name. Still remember the Excel sheet just now? I put here MD here. So this is the variable name. Right, I know the series. So this is the variable name MD. MD is a very demand. I use a short form now. It depends on what name you want to input inside, right? I put MD now. I put MD here. So in the command here, you use this one. Okay, I put MD. So how to read? Actually, LNMD is a new name. So equals the log in the parentheses. The red color is a command to log your series. To log what series? To log the MD series. The purple color is the variable name in your Excel sheet. The variable name in your Excel sheet is called MD, right? So the black color here is the view name. It's a name. You can give any name, but to be consistent, I put LNMD. You can put Doraemon, you can put Pikachu also can, right? But I put LNMD, right? So this is the way for me to put in the command. If let's say you want to create additional series, which log the series for the y, for example. So I put LNY equals to log in the parentheses y. Right? If the data series is you have a y series, right? You have a y series, for example, y. Then you just change the command here. Just put the LNY, for example, equals log in the parentheses y. So this is how we don't need to put color just for your reference only, okay? So this is the view name, and this is a command, and the y is my variable in the Excel, okay? So this is how we generate the command in the EViews. So what next? I want to log my series, right? I copy this one. No, I'm going to copy. You go to the EViews, go to the quick. You go to the quick and then generate the series. You type your equation. So I type LNMD equals to log in the parentheses ND. So this is I put it, as you observe in my work file here, without the LNMD, right? Without the log. Now just click OK. So you see that LNMD is here. Then you will start to ask, why I need to log the series, right? What's the purpose for me to log the series? So actually, this one is one type of the modeling. Actually, in the economics, when we want to estimate the models, right? So what we suggest here is for all the macro variable series, we log before we run the regression. But on the condition that the series do not contain negative values, and the series is not in the ratio series. Not in the ratio means that, for example, economics, we can have the ratio series, like the export over GDP ratio, right? Export over GDP, import over GDP, etc. So have you logged the series? Yeah. So run your unit. So then you actually log is want to minimize the scale. So yes, if you want to take a log, you can draw them in the same picture. Open them and then open and then open. are two series here. One is 21.118, the other one is 1.48, but E plus 0.9. Quite huge, right, the number? E plus 0.9 means that you have additional 70 at the back here. 148, 0.0000000, right? It's measured in the currency, ringgit Malaysia. But after I log the series, I only, the series, for example, in the year 1963 becomes 21.1180. So if you run this equation, if you run, for example, if you perform the series with determinants for marine demand, then you include the income inside, then you run the double log models, then actually the variable will become much more, something not variable, like the coefficient will become much more meaningful as compared without the natural logarithm. So if I want to build the graph, then just go to the, maybe if you want to go for the multiple graph first, you can OK. So what will come up? Multiple graph, right? So this is the original series with the MD, and this one is in the natural logarithms, in the log form. So both of them also training upward, right? But the fluctuation is a little bit same, a little bit fluctuated around 2000, right? 2000 and marine demand, means that this money is a water money, right? So the money supply actually what I use I use the MD here because it's a water money, right? Actually it's refer to money supply in the economy. But in the economy, there is a theory stated that money demand equals to money supply. That's why money supply normally used as the proxy for the money demand. Because it's an equilibrium. Money demand equals to money supply in the field of economy. So I use the money supply for the money as a measure, as an indicator for the money demand. So here, that's why training hour almost same, but you can see a little bit different, but because of this one is a measure in the ringgit, right? This one in the log. So actually it's minimize the skews only, right? Minimize the skew. So what you can observe from this graph? The talk about not in the log, log or not log also same. So what you observe? Can I say the series is non-stationary? Yeah, training outward, right? It's going up, like the GDP, right? Like the GDP is going up, going up. Is it they have a possibility that the series will be stationary? Yeah, there's a possibility, right? The series might be stationary after first difference. It might be. Let's test it. So let's test the result. So before I test it, maybe I'll show you how to run the linear test first, right? So you can go to I concept is the money demand LNMD. So you click on the LNMD, then I go to view, then I go to the linear test, then test it. Use the standard linear root. So if you want to use the standard linear root, so okay, I repeat the step again. You go to view, right? Once you click on the series, I go to view, then I choose the option number 8, linear test. Click on the standard linear test. Standard means standard, because nowadays the econometric already as you observe there already a lot of the linear tests here have a breakpoint, have a stationary linear. So we cover the theory first, the standard one. After that, once you stable, then you can move forward already. So under this linear test, once you scroll down, there are a lot of linear tests. There's the amended equivalent, which we discussed just now. It means that the original is equivalent. After that, extend it, amended it, include the lag dependent variable inside to accommodate the autocorrelation, right? So these are amended equivalent. We also have the Phillips balance and the KBSS. So these are the three tests we discussed just now, and also what they use in the research. Actually, there are also one more test called unparalleled, which is confused by my last semester student at unparalleled, right? So this is much more interesting, and also what they use recently to complement each other with the KBSS, Phillips balance, and amended equivalent. And then not what they use one is the PRS, and also the ERSP, ERSP. This is not what they use, seldom used one. So let's see the what they use one. I want to test for the amended equivalent. Then what is the question just now is test for the with the drift, with the intersect. Okay. So here you can see test for the unit in the level, first difference and the second difference, right? So we first start with the level first. It's a normal procedure for us to start with the level because I want to see whether the series is stationary in the level, right? So I want to test for the level first. I know where is the hypothesis? Where is the rationale? The rationale is unit root, right? This is my rationale. My hypothesis is rationale is unit root. Rationale, unit root. Unit root, you are what I put you are. Okay, alternative no unit root. So this is my hypothesis. So after that, the second portion here, include in a test equation. So what you understand about the test equation? Changes, right? The changes yt on the yt minus 1. If you want to test with the intercept, then put the drift inside and then plus the ut. This is a test equation for intercept. Then after that, lag is the lag dependence variable just now. The lag, the p, right? The amount of the changes, the lag for the dependence. The lag for the dependence. So how many lag you want to put inside? Because now we not sure, right? So we let the system to decide for us, right? So I use the automatic selection, means that ask the EView to help me to select the appropriate lag dependent variable that suits my equation. Because I have a data set on the right demand, so I do not know how many lag. So I let the EView to help me to choose the appropriate lag length that help me to mock up the autocorrelation. Means that minimize the criteria. Minimize because the minimum, the better the model stuff, right? So the minimum one. So based on the maximum that is 10, you cannot do anything with this because this one frequency it depends on our frequency. Because how many observations I have? I have 50 something observation, right? I have 52 observation. Is it 52? I cannot see. This EView 32 at once. Let me call this one. But it's my based on the PowerPoint. Here, 58 observation. So I have 58 observation in total. So the EViews already use a certain formula to help me to calculate, and it shows me that the maximum lag I can put inside is 10. It means that the maximum lag dependent variable is 10 only. I cannot more than that. If not, I have not enough degree of freedom, right? So I maximum 10. So how many EViews will give me, will return to me? It depends on the criteria I use. So I said, okay, so this is my result. Okay, this is my result. How to read this result? How to read this result? So this is a result. Congratulations. You already come here, right? So automatic input test for your mind demand. So this is your result, and this is your critical value, and this is your p-value, right? Okay. This is your test equation. Changes in your y, right? Changes in your y means changes in your mind demand on the lag for the mind demand, and the sorry, not lag. It's a mind demand p minus 1, right? And also the lag for the dependence variable. Only one. Only one. It means that the lag length based on the SIC, the system says only one. Cannot up the other correlation. So only one, and then only one. Okay, only one. And then they come up with the test statistic is use this coefficient divide by this standard error. Then come up with the test statistic and then 2.83. Here. You know how this works? Yeah, I copy this. Too small, right? You see this? Okay. That's my word file. Go to the word, W-O-R-D, word file. So the test statistic just now we said is the coefficient for the t minus 1, right? This is 1. This is my dependent, this is my what? This is only one, right? One series, the series. And then on the yt minus 1, right? So this is the yt minus 1. And in the parenthesis, minus 1 means refer to the lag 1 period. Lag 1 period in the EViews. And this is the lag dependence variables. Lag one also D, L, and D in a parenthesis minus 1. So it's a length, one dimensional variable. Oh, so sorry, I forgot to turn it. Yeah, I'm not so familiar with two screens in front of me. Yeah, thank you. After that, I finished all my text and already you said, no, you don't see the screen, right? Enter. Okay, now. So, yeah, I don't know why here got two screens. So here, and then here got like one period. So what the test statistic is, use this coefficient, right? Divide with the standard error for the coefficient, then you will obtain the test statistic. This is how the test statistic comes out. This is what we show you just now, right? What we show you just now is my test statistic, the augmented Wikifolder. Go back to the ADF just now. Is somewhere around here. Yeah, this one. Same test statistic as Wikifolder. The coefficient, right? The coefficient yt minus 1 over the standard error for this coefficient. Right. So same thing. You use this coefficient, divide the standard error for the yt minus 1, for the coefficient, you will get the test statistic. So this test statistic, this is a test equation. So same here. It's the same test statistic. But you can see the different probability, right? 0.065, right? It's different with this probability. Why? Because this one is the probability for the test equation to see whether this coefficient is significant or significant in that particular test equation. But this one is compared with the critical value. Because this is similar to critical value, right? So it's compared with the critical value. So have a different set of the what we say, the different set of p-values. So this is compared based on the critical value. So negative 2.835. So is significant at 10%. So the test statistic is significant at 10%. So if the question asks you, is it the test statistic significant at 5%? No. So in that condition, the series actually is non-stationary at 5%. But it's stationary at 10%, right? So this is how we draw the conclusion based on the compare with the critical values. Then you will, because maybe your first time to do the comparison, right? Perhaps you can draw like this, right? Yeah. So this is much more on the left view, right? So if I say, I want to ask you, is it the test statistic at 5% or not? The critical value is 2.91545. So here is the rejection region. So if the test statistic fall in this region, then you will say you will reject the first term. Reject the first term. So what is my test statistic? Negative 2.8 is for here, right? Negative 2.8. So it's the